Okay, this is part two, so let's finish these problems. So here they want you to find the five number summary, right? And construct a box plot and whisker, state whether there's any outliers, and briefly describe the distribution, skew to the right, skew to the left, or symmetric, right? The first thing you should do is put these values in the calculator to save time, right? So the first thing I'm gonna do is I'm gonna say you have to find your five number summary, which is the minimum, Q1, Q2, which is the same as the median, right? Q3, and your max, right? And then after that, you can find the outliers and whatever you're missing from here. So let's put this in the calculator, right? Let me see, 1 second. Let me put this in the calculator and let me share this with you. So we turn on the calculator, we clear these, we need to plug the values inside. Let me see. So I already did this stuff, just in case if you want to sort it, right? So you put L1, and then you can sort this stuff, right? So stats, edit. So now everything is in order. Now we can do stats, calculation, right? And we can find, we can see the five numbers somewhere here, right? So Q1, the minimum is 27, Q1 is 29, the median is 30.5, Q3 is 34, the max is 34. Okay, so the first thing I should do is what? Find those points, right? So this is 30, 27 here, then we have 29, and then we have 30.5, right? So 30.5 is maybe around here, not really. 30.5 is around here, and we have, what else? We have the Q3 and the max are the same, so those are at 34. So now you just trace this, sort of, right? Like this, right? Okay, so I'm just gonna do it like that because it's easier for me to draw it. Okay, so you can see what's going on. So this is my minimum here. This is my whiskers, right? Okay, and there's no whisker to the right, right? Which implies that this is gonna be a right skew distribution, right? So you can see the median is to the left, right? So this is your five number summary, right? So this is your Q1, Q2, and this is your Q3. So you can see clearly that Q2 minus Q1 is less than Q3 minus Q2, right? You can see that clearly here. Okay. Okay, so now you need to find out so that this, you can say that this is a skew to the right, right? Skew to the right. Oh my God, you guys cannot see that. Okay, give me 1 second. Let me share this with you. I'm sorry. Let me share this with you really quick. Okay. I apologize about that. Okay, so like I was saying, the easy way to do it on the test, let me rewind myself then because you guys didn't see that. Okay, so once I find my points, my median, my minimum, my Q1, my median, my Q3, and my max, which are the five number summary, I can just you know plug those points in the number line, and I can just do this, right? I'm gonna do it this way because it's easier for me, because since I'm doing this by hand, it's much easier doing it that way. Okay, so now there's no whisker on the right side, but there's a whisker on the left side. Okay, and you can see clearly that this is a skew to the right, right? Or positive skew, right? Because the median is to the left, right? So you have something like this, right? So when we have a distribution skew to the right, the mode should be here, right? Then the median should be here. So this is the mode. The median should be here. And the mean should be here, right? Therefore, we can say the mode is less than the median, and the median is less than the mean, right? We can say that, right? Now, remember, the mean gets more affected by outliers, right? So that's the reason. That's the reason that we have to put the mean to the right. Now, we need to find out if there's any outlier. So first, we need to find the interquartile range, right? Which is Q3 minus Q1. So this is going to be 34 minus 29, and that's going to be just 5, right? And now I need to find the interquartile range to find the outliers, right? So this is going to be Q1 minus 1.5 IQR, you know this, and this is Q3 plus 1.5 IQR, and if any number is below that or above that, then that means that that's an outlier, right? So Q1 is what, 29 minus 1.5, IQR is just 5, right? And then you can do Q3, which is 34 plus 1.5, and the IQR here is what, 5. So you just need to compute, right, this stuff. And so this is 29, and then you use your calculator. You can do whatever you want at this point. So this is 7.5, right? And then 34, 1.5 times 5 plus 34, you get 41.5, right? So that's that part. Yes, and then the other part should be 29 minus 7.5. That's going to be 21.5, right? So any number below 21.5 or above 41.5 will be an outlier. I don't see that here, right? I don't see any number below 21.5 because our minimum is 27 and our max is 34. And in order to be an outlier, it has to be more than 41.5. So we don't see that here. Now, in the book, they mentioned that these are outliers, right? Mild, I think they call that mild outliers. Sometimes we need to look for the extreme outliers, right? I'm not, well, if there's no mild outliers, obviously there's no extreme outliers. But what you can say, if you need to find it, let's say on the test, there's something like extreme outlier, instead of putting 1.5 IQR, you will do this. 1.5 Q1 minus 3 IQR, right? And then you do Q3 plus 3 IQR. So that with this range, you will find the extreme outliers, okay? With this range right here, with the 1.5, you find the mild outliers, okay? That's how you do it. I hope you understand that. But since there's no mild outliers, obviously there's not gonna be extreme outliers. There's no outliers at all in this data, right? Because everything is so kind of close together, kind of clustered together, right? So that's the reason we don't have that. Let me briefly explain to you something about the distributions. I think you know this stuff, right? But anyway, if the distribution is symmetric, which means the mean equals the median and equals the mode, okay? If the distribution is symmetric. If the distribution is skewed to the right, like our example, let me erase this stuff, right? Oh my God, sorry. If the distribution is skewed to the right, the mode is gonna be to the left, right? The mode is here, then the median is gonna be here. And here, this is gonna be the whole median, and this is the mean. Just remember, right? Whatever, if it's skewed to the right or to the left, the mean has to be at the extreme, right? Because the mean gets affected a lot by the outliers. So that's the reason the mean is to the tail, right? Now, if you go in the other way around, right? If this is basically skewed to the, let me fix this a little bit more better. This is skewed to the left, right? So here now the mode is going to be here, right? Then you have the median here, and here you will have the mean. Okay. So in this case, the mean is less than the median, and the median is less than the mode. In this case, the mode is less than the median, and the median and the mode is less than the mean. Okay, make sure that you remember this thing. Okay, there's also something called Pearson index, right, of skewness. So basically, with this, you can find the distribution is positive skew, negative skew. If you want to find out later on in the course that this is just the mean, 3 times the mean minus the median over the standard deviation, right, of these samples, the sample standard deviation, right? If you have that, okay, you have that, right? Actually, this is not the mean, this is the median, I'm sorry. So this is the sample mean minus the median over the standard deviation of the sample, right? So that's how you can find a Pearson index of skewness, right? If that's between, if this number is like, let's say, greater than 1, greater or equal than 1, then that means that that's positive skew, right? If P is less than 1, that means that that's negative skew, right? And if it's between 0, like a 0.6, 0.2, 0.3, that's in between the range of normality, right? So basically your distribution will be normal, right? But sometimes, depending on the author, sometimes they say anything from 0 to the right, that's going to be skewed to the right. So for example, the problem that we have, we get 0.6, right? If you do this formula, right? So that means that it will be skewed to the right, but depending on the author. Usually, when in practice, if it's 0.6, then I will say it's normal. However, in this problem, it's very obvious, right? Then this is skewed to the right, okay? Okay, so that's that question. I mean, you don't need to do all this stuff. I'm just explaining to you, right? So the answer, once you have this stuff, right? Once you find this stuff, you graph this, right? You graph it, you tell me what it is, and you find the IQR and the interquartile range, and you find out that there's no outliers, you're done, right? You don't need to do all this stuff that I'm talking right now, right? I'm just explaining to you, okay? So that's the end of that problem, okay? So it's not that difficult. Next, here. It's an emergency service wishes to see whether a relationship exists between the outside temperature and the number of emergency calls it receives from a 7-hour period, right? The data are shown. Find the sample correlation coefficient and describe what it happens accordingly. So this is very easy. You just need to calculate the correlation coefficient, right, of this sample. Most likely it's going to be linear. Actually, it is linear. So you just plug your data, right? So here, this is X, this is Y, right? These are my variables. You can find XY, and then you can find, actually you find X squared first, X squared, Y squared, and you need to find out what is the XY, right? So you just plug, right? So X is 68, 74, 82, 88, 93, 99, and so on and so on and so on, right? 101. Then this is 7, 4, 8, 10, 11, 9, 13. And well, we need to square it, right? And you're not gonna do this by hand, right? This is gonna take you forever. So you have to use your calculator one more time. That's the reason your calculator, you have to bring it, no choice, right? So let me show you how to do that. The first thing you should do is input your data, right? So here you have to input your data. So let me clear this up. And now you enter the values for X. So 68, 74, 82. You can do faster, but I'm just doing this because I have to explain. But if you're doing this in your by hand, you should do this very, very fast. And then this is 101, right? So 101. Now for L2, right? You have to put 7, 4, 8, 10, 11, 9, and the last number is 13. Now you need to find the values of x squared, y squared, that thing, right? So here you're gonna plug in L3, you're gonna plug L1. So you're gonna do second L1 square to save time, okay? So that's your L1 square, right? So now in L4, you're gonna put y square, right? So you enter and you put L2 second, L2 square, right? So that's the y square, right? And then if you need to find the cross product, right? You just do x times y, right? So you do L1 second, L1 times second, L2, right? So that's the cross product between x and y. Click enter, and then you get your values. So now you go back to this and you write these down in the table that I was doing on the paper, right? So you write 46, 24, 5,476, 6,724, 7,744, 8649, 9801, and then you get 10,201. Now you do for y, right? So y will be 49, 16, 64, 100, 121, and then the other one is 81, and then the other one is 169. Now you do the cross product, right? So this is what? 476, 296, 656, 880, what else? 1023, and then you add 891, and this is 1313. So you are done. Now you need to find the summation of all those values, right? Summation of x, whatever that is, right? Summation of x, summation of y, summation of c, I'm sorry, not c, x squared, summation of x squared, summation of y squared, and then summation of xy, okay? So you need to find those values. Now the question is how I do that fast, right? That because we don't have too much time. So you need to go to stats and you go to calculation and you press, now you press the second one, 2-bar stats, right? So you press one, enter, 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 enter. So you see where it says summation of x, that's the summation of x. So summation of x equals summation of x equals 605. Now you need to find the summation of y, right? Which is the other value. Summation of y equals, let's find it, what summation of y? Here, 62. Now you need to find summation of x squared, right? So let's find out what is x squared. I think I see it here somewhere. Here, summation of x squared is 53,219. Then you need to find out summation of y squared. So that should be here. So that's 600. And now you need to find out summation of xy. And the cross product is here. You see, is 5,535. So basically, you're done at this point with the calculator. There's nothing else that you need from the calculator. So now we stop and then we go back to the test, right? That I was doing. Okay. So now we're here. I already typed those values, right? So now we need to find the correlation coefficient, right? So the correlation coefficient is the cross product or the covariance, right? Because this is just the x bar minus x times y bar minus y, right? So you know that. So this is the covariance, and this is the square root of the standard deviation of x, and s, y, right? Let's call that. Okay, now we need to compute this, right? So what is xy? We need to compute that, right? We need to compute sx, y, and that's the kind of stuff. So let's find the mean first, right? So the mean, I forgot to write it down. Okay, no problem. So let's go back to the calculator really fast. What is the mean here? the mean of X is 86 point, let's round it to one decimal place, 86.4, and the mean of Y is 8.9. Okay, so let's go back to the test. So okay, sorry about the back and forth. Okay, now we need to compute this, right? We need to compute this. Now we have everything. Okay, so xy is the cross product of this, right? This is in your textbook, I believe. Okay, so this is over n. So the cross product or the covariance equals x times y. You have that here, 5,535 minus summation of x is 605 times summation of y is 62 over your sample size. Let's see, what is the sample size? I forgot to write that down. So n equals, so we have 2, 4, 6, 7, right? I believe, yeah, 7, 1, 2, 4, 6, 7, yeah, 7. So this is 7, okay? So now we compute this, whatever that is, right? So let's do that. 5,535. 5,535 minus this thing. I get the covariance is 176.4286. And now I need to find standard deviation of those values, right? So I need to find SXX and SXY, right? So SXX is what? I need to find it. X squared minus summation of X, the second power over N. We have all those values here, right? So X squared is this thing, right? 53,219 minus 605 to the second power over 7, right? Okay, over 7. Let's calculate what we get here. So we need to do 605 to the second power divided by 7, 53,219 minus that value. I get 929.7, and SYY equals, this is YY, yeah, I need to find it too. Y squared minus summation of Y to the second power over N. So S sub YY equals Y squared, so that's 600 minus 62 to the second power over N, which is 7 in this case. So 62 squared divided by 7. Now 600 minus that value, I get SYY equals to 50.8571. Now we can calculate that for the Pearson correlation coefficient, right? So S sub XY is 176.4286 divided by the standard deviation of X and Y. So that's going to be well, these two together, right? So 92.929.7 times 50, right? That was what, 50.8572. Now compute this, right? So R equals 176.4286 divided by, okay, let me do that here, 929.7 times 50.8572, and the square root of that. And then we have 176.4286 divided by this thing. So I get R equals 0.8113. So you can see the correlation is strong, is positive correlated, right? So it's a strong too, right? So what's the question? Emergency service wishes to see whether there's a relationship between exits between the outside temperature and the number of emergency calls it received for a 7-hour period. The data are shown. Find the sample correlation coefficient and describe what happens accordingly, right? So you can see here what happens. So the correlation coefficient is positive correlated, which means that as one variable, as X goes up, in other words, as temperature goes up, the number of calls goes up as well, right? Over this 7-period time, right? I also want to clarify something about this. When, for example, if I have 0.8 as a correlation coefficient, let's say, right? And if I have 0.4, it's very tempting to say, oh, the correlation coefficient, let's call this correlation coefficient R sub 1 and R sub 2. It's very tempting to say, okay, the correlation coefficient of R1 is twice as good as the correlation coefficient of R sub 2. That's incorrect. That would be very that's very tempting to say, but it's incorrect, because by the definition, the total variation of Y explained by X, by definition, right? It's 100 R squared, right? So this is the coefficient of determination, okay? So basically, what you need to do is 100. If you want to compare these two, what's the how much strong it is? So you will say 0.8 to the second power, in contrast with 100 times 0.4 to the second power. Therefore, this is 0.64, right? So this is 64% about that, right? And this one, or 0.64, and this one is about 16, so this is 16%. So this correlation, point A, is 4 times as strong as the R2, right? So don't confuse just comparing these numbers, because this is the definition, this one right here, of the correlation coefficient, right? You need to understand that in order for you to compare two correlation coefficients. Don't get into the, you know, the idea that, oh, because this is 0.8 and this is 0.4, this is just twice as strong. This is the definition, right? So 100 R squared. Okay, I hope that makes sense. Now the last problem is very easy. They're asking you for the probability, right? So this is they're asking you if they're more mutually exclusive or something. Come on, this okay. So if this notation confuse you, right, you can just write like this: the probability of A equals 0.3, the probability of B, like I did in class, right, is 0.25, the probability of C equals 0.60, the probability of A union B equals 0.55, and then the probability of B union C equals 0.70, right? So the first one is asking you, what is the probability of A complement, right? A prime, they call in your book. Most likely in statistics, we call it like this, right? I mean, that's more common, right? And then this is just what? 1 minus the probability of A, right? So 1 minus the probability of A is 0.3, so this is 0.7, done. B, probability of B complement. B complement is just 1 minus the probability of B. So this is 1 minus the probability of B is 0.25, so this is 0.75. C, the probability of C complement, right? C complement is 1 minus the probability of C. What is the probability of C? 0.60, right? So this is 0.4, right? You can do that in your head. And then D, what is the probability? They say, are A and B mutually exclusive? So I have to use the addition rule, right? The probability of A union B is the probability of A plus the probability of B, right? And minus the intersection, if you want to use the addition rule. So you know that there's no intersection because let me move this around. You know that there's no intersection because they're mutually exclusive, means the intersection should be 0, right? Let's see. So the probability of A union B is given. So you know that this is 0.55. The probability of, okay, so there's a probability, we need to solve, we need to find out if what's the intersection basically, right? So you can say the probability of A intersection B is the probability of A plus the probability of B minus the probability of B A union B, right? Probability of A union B. So probability of A is a 0.3, probability of B is what? 0.25, and probability of A union B is 0.55. Guess what? This is 0.55 is canceled, so the intersection is 0. Therefore, the probability of A intersection B is 0. Therefore, these events A and B are mutually exclusive. I think that makes a lot of sense, right? Now we have to do the same thing for the other one, right? So for E, the probability of B union C should be the same situation. Probability of B plus the probability of C minus the intersection. Okay. And actually I compute this already, right? So this is intersection C, B, C, and then I can put the union here. Okay, so probability of B intersection C is the probability of B, which is 0.25, plus the probability of C, which is 0.60, minus the intersection, the union is 0.70. So let's calculate this. So this is 0.85 minus 0.70. So this result turns out to be 0.15. So it's not equal to 0. So there's an intersection or there's an overlap between B and C. Therefore, this is what? This is not mutually exclusive. Therefore, not mutually exclusive. Okay, so that's basically the test. I don't think it's difficult, right? I think it's pretty straightforward. Okay. Sometimes, if you want to find out the regression line, right, you will need to do some calculation here. So usually we want a regression line, right? Or we call the line of best fit. So we want A plus BX, right? So we want some line that represents this correlation coefficient, right? If you want to find out that, you can do B is equal to the cross product or the standard deviation of X. So if you want to find out what that is, we calculated already that stuff, right? SXX was what? It's somewhere around here. SXX is 929.7, 929.7 over SXX, right? SXX is actually, no, that's not right. SXY, right? I need to calculate first the cross product. So the cross product is 176.4286, 176.4286, and I need to find the standard deviation of X is 929.7, 929.7. So this is your B value. So you just divide those two things, right? 176.4286 divided by 929.7. So that turns out to be 0.1897, right? So that's the cross product, and you get your y-intercept that way. Okay. And if you want to find the A value, right? So that's basically you need your means, right? So basically, y hat to find A value, basically you just do y minus bx. So you need the mean of y, which is 8.9, minus b, which is this value that we found here. Let me put that here. A equals the y value is 8.9 minus b, which we calculated 0.1897, and this b represents basically your slope, right? And x bar is 86.4. I'm sorry, 86.4. So that would be 8.9 minus whatever that is, right? So that's your A value. Okay. Yeah, so let's see, 0.8797 times 86.4, and this is 16.39. And if you want to calculate this is 8.9 minus this guy, and this is negative 7.5, let's say. And you just need to write the equation, right? So the equation will be A, yeah, which is negative 7.5 plus 0.1897x. So that will be your regression line, right? This thing right here. Okay, this will be your regression line. And you might say this is so much. Yes, I agree. So that's the reason we have software, right? However, you can use your calculator to find these values, right? We have the data already plugged in the calculator. So if we go back to the calculator, you go here, you clear this up, and you put stats, and you go here to what it says, linear regression, A plus BX, and well, you calculate this stuff, right? So there you go. The B is 0.1897 like I have, and the slope, I'm sorry, the y-intercept is 97.5, and the slope is 0.1897x. So let's go back to the slide, right? Let me see. What is the slide? Here, right? So the slide is here, and this is what I compute, right, when I did it by hand. Let me show you. Yes, so I have the same value as they have. You see, 7.5 is my y-intercept, and my slope is 0.1897. Done. There you have everything about this thing, right? Of course, this is just simple example because this is linear regression, right? There's no more parameters, right? Or it's not a polynomial empirical model, right? But this is how you start, right? With linear models. And since this class is, it has some, we cannot go beyond the scope of this course. This is just basically what you need to learn in this class. So I show you already how to calculate the correlation coefficient. I talk about the coefficient of determination. I talk about the definition of the correlation coefficient. I talk about the regression line. I show you how to calculate also the correlation coefficient. I also show you how to calculate the probabilities of mutually exclusive events and the complements. And we went over how to calculate or how to compute or how to do the 5-number summary, draw the box plot, find the 5-number summary, find the interquartile range, find if there's any outlier in the data, and also if there's an extremely outliers in the data. And I also explained to you the distribution of if it's metric, skew to the right, skew to the left. Sometimes also, I forgot, there's something called kurtosis, right? So the kurtosis can make this more steep. So that means there's less variability. And sometimes you might have the kurtosis maybe like this. So that means that there's more variability, right? So when the kurtosis is like this case, yeah, it's tedious to compute by hand. Usually you need software to do that. But usually we don't consider that a normal distribution at some point. So we don't use that. These two we will need to compute it to actually I will need to compute it to actually tell you what it is, but we don't need to worry about that because that's not a test. And then sometimes they call that, let me go back to that. So sometimes they call that this one is Meso-Curtis. This when you have it like the normal distribution when k equals 0, and then when you have it like when k is less than 0, this is called Platy-Curtis, and then this is Lepto-Curtis. Okay, so but you don't need to know that for this test. Okay, but I'm just explaining it to you. Okay, that's basically it. Okay, thank you. Have a good night, and I hope you do well on your test.